All right, and welcome back to another homework help video. This one is the last one from Unit 1. We are covering Lesson 10. I know. What do you know? All right, so we'll start with the ready. We're starting off with number 1. All right, so let's zoom in just enough to be able to see it. Okay, using the recursive rule, f of n equals f of n minus 1 plus 8, and f of 1 equals negative 10, select all of the statements below that represent the sequence. Okay, so let's start off with something we definitely know. All right, f of 1 equals negative 10. This means that the starting value, oh, it didn't like that one. This is the, well, erase and try again. This is the starting value, right? So this is our starting value. Needs to be, like, 1 needs to go to negative 10. So right off the bat, f, I'm seeing a starting value is 8, right? 1 goes to 8. So that does not work. All right, so we're going to cross that one off. And you know what? We'll introduce a red. Let's introduce a red here. All right. So definitely not f. All right, what else are we looking at? Are there any others that have a starting value right off the bat? No, I think that's the only one where we see f of 1. All right, so that's the first one we can eliminate. Then let's go back to our rule, okay? So recursive, it says that the current step is the previous plus 8. So we need to be jumping up 8 at a time. So does A, right, in A, do we jump up 8 at a time? Yes, we do, right? 8n, which means that each step we take, or each time we increment n, if we increase n by 1, then we will jump up by 8. So A is okay for now. B doesn't have any information. We would just have to check if 2 works. So we'll go check that in a second. C also doesn't have anything about our jumping up by 8. Here, we'll just underline. This is, each step is 8. Right? Step needs to be 8. Okay, that's what we're checking right now. F of 7 is 38. That does not have a step involved. Here we go. F of n equals 8n minus 2. So this one is okay. Sorry, 8n minus 2 and 8n minus 2, right? So these will both work, right, as far as having the correct step. This one also has the correct step, so that's okay for right now. And the rest of them do not have step information. So now let's check again. And maybe this time we want to just, right, so we know that some of them work. We know that F definitely doesn't work. But what we can do is now build a table just to make sure, because a lot of them seem to have information about specifics that might work. So F is not the right table, right? If we plug in 1, we should have negative 10. So F is not the right table, but we can make the right table, all right? So let's do that. So n and f of n. All right, so if n is going to be, let's just do 1, 2, 3, and 4. How about that? 1, 2, 3, and 4. And we know that the first step needs to be, or sorry, the first value needs to be negative 10. All right, and you know what? We'll do this in black. That's fine. Negative 10. And then we know that we're going to add 8 each time. So negative 10 should be there. Negative 2 should be here. If we add another 8 to that, right, we should have positive 6. And if we add 8 to that, we should get 14. All right, so those are our first 4 steps. This will let us either eliminate or confirm some of the other items. So B right here that we're looking at, let's look at B real quick. That says that the second term should be negative 2. And in fact, it is. So B works. This is correct. B is good. C says that the second, right, if we plug in 2, we should get 4. Well, if we plug in 2, we get negative 2, so C is out. It definitely is not C. That's not one of the correct answers. D says if we plug in 7, we should get 38. Well, we could keep going with our recursive rule, I suppose. Do we want to do that all the way to 7? I'm not sure we want to keep going all the way to 7. But you know what? We can do that. Let's keep going all the way to 7. So we have 4 is up here. Let's just add 3 more, 5, 6, and 7. And what do those go to if we extend our table? Well, we're going to add 8 each time, so we need 22, and then 30, and then 38. Right? That wasn't so hard, right? Just adding 8 each time. So let's see, does the 7th number, is it 38? Yes, it is. So D, that is correct. For E, this looks like an explicit rule. Actually, A and E are both explicit rules, right? So this one is explicit, this one's explicit, and it looks like G is also explicit. All right. H is giving us a point or a pairing. It says that 4 goes with 14, and that is correct. We see that right here. 4 goes with 14, so H is correct. And then 10 and 62. Well, I don't really want to add 3 more rows to this table because I'm kind of out of space, but we can say, oh, 3 more steps would get us to 10, right, for our input, right? 3 more steps would get us from 7 to 10. And if we do 3 times 28, or sorry, 3 times 8, that's going to be 24. If we add our 24 to 38, that would be 62. So this will also work, right? And that's sort of like a plug-in and check. So that's good. And then we got to look at A, E, and G as far as explicit rules. So let's write our explicit rules without looking at A, E, and G. Let's just write our own explicit rule and then see which one it matches. So we're going to actually do this one in purple. So an explicit rule. All right, our step is 8. So we're going to have, I'm doing this above, f of n equals, each step is 8. So we're going to have 8n. And there are actually 2 ways we can do this. One is 8n, and then we're actually going to have minus 18. Right, so that when we plug in a 1, we'll get negative 10. That's one thing we can do. And oh, that actually matches up with G perfectly, right? 8n minus 18. So that matches perfectly with G. But the other way we can do it is to have an n minus 1. Right, so we actually don't have much space. Let's see if we can go a little bit above. We can, all right. So the other way that we can write this is with an n minus 1 term. So f of n equals, and what we do is we put our starting value, which is minus 10, negative 10, and then we say we are adding to that 8 times n minus 1. 8, oh, did not quite like that. There we go, 8n minus 1. Right, so that when we plug in our first one, like our first step, we don't actually add anything because it's times 0, right? 8 times n minus 1 or 8 times 0. So we just have negative 10, and then we're adding 8 each time. So does that match either of the ones we have here? Well, this is 8n minus 2. And we said that 8n minus 18 was correct. So it definitely can't be A, right? So let's get rid of A here. Right, definitely can't be A. But could it possibly be E? Well, 8n minus 2 minus 2. Well, that's actually saying, oh, if we normally have negative 10, right? If we normally have this, oh, let's go here. If we normally have this negative 10 plus 8n minus 1, then we should be able to have negative 2 plus 8n minus 2, right? It's just shifting our start point, but we could do that. That's a pretty cool shift that we learned how to do. So actually, E is correct. It's going to be 8n minus 2 minus 2, which is a little bit weird that that's how it works. But because like the minus 2 and the minus 2, it looks a little funky. But that does actually match up. It just changes our start point to the second term instead of using the first. So, okay, that was a lot of work for the first one, but that's okay. We are getting ready to sort of test ourselves on our ability to use recursive and explicit rules for sequences. So, this is good. It's a lot of good work. Let's keep going. All right, here we go. Determine which of the explicit rules represent the table of values. All right, explicit rules. So this follows really well from the previous, right, where we were just doing, we had a recursive rule, which let us build a table, and then from the table we could see like the first step or the second step, and change where our start point was. And I have a feeling this is going to be asking about start point stuff a lot. So let's look at this in depth. All right. Determine which of the explicit rules represent the table of values. All right, and we're selecting all that apply, so we should make note of that. Select all that apply. All right, so what do we know? Well, let's first look, what's the jump? From 4 to 20, from 20 to 100. Is this a geometric or an arithmetic? Well, from 4 to 20 is either plus 16 or it's times 5. Right? And from 20 to 100, it's either plus 80 or it's times 5. So the thing that matches up is times 5. And that just didn't work for me, but that's okay. Times 5 times 5. All right, so our common ratio needs to be 5. Now our starting value, well, it could change. So our starting value could be 0.8. Oh, okay, so let's just check each of these. So if we plug in a 1 for A, we're looking at A right now. If we plug in 1 and we have 0.8 times 5 to the first, that would be 4. And our thing in parentheses, or the thing with the exponent, with the power attached to it, is a 5. So A is going to work. If we look at B, we have, it looks like 20 is now our common ratio. So 20 being our common ratio is not correct, right? The thing attached to our exponent needs to be 5. So these are actually switched, right? If these were flipped, it would work, but since they are not, they're in the wrong place. We're going to go with not correct on B. Here we go. 5 times 4 to the x. Well, 4 to the x, that's not our common ratio, right? This needs to be a 5. So maybe if those were flipped, it would work, but in this case, it does not. And actually, even if they were flipped, there's something a little bit wrong with that. So that's incorrect. Here we do have 5 is our common ratio, which is good, right? So 5 is where it's supposed to be. The x minus 1 means our first term needs to be 4, right? So the x minus 1, so this 1 and this 4 match up well, right? Because there's a 1 and a 4 here. So that will work. D is correct. And then using that same sort of approach, so let's see, the thing attached here, we already know this is going to be wrong. The 4 here, that's the base, we already said that the common ratio needs to be 5, right? So the thing, right, the number that is underneath the power, or the x minus 1 or x minus 3 or whatever it is, that needs to be a 5. And since the 4, we know that E is going to be incorrect. And now let's see. All right, so this does have a 5 where it needs to be, so that's good. X minus 4, well, let's see. If the fourth term is 500, then this will work. The fourth term is 500, so this one works. So our correct answers are A, D, and F, right? And we'll just re-emphasize that. A, D, and F are the correct answers here. So that's good. Let's move on to the next question. It's going to be on the next page. Do we have 5 to do? We do. All right, we're doing 5. Oh, we don't have the instructions on this page. Let's go back real quick. Read the instructions. Here we go. Use the given information to create the other representations for each arithmetic sequence. Okay. So we're using this. What do we have? We have a table on the first one. So we're going to use the table to create a recursive, an explicit, a context, and a graph. Wow, okay. So we've got a lot going on here. All right, let's start off with our recursive. First, from 8 to 11, that's either multiply by 11/8 or it's add 3. I hope that it's going to be add 3 because that would be a lot cleaner. 11 to 14 is also add 3. Okay, so cool. Our step is just plus 3. This is going to be, oh, did it already say it was going to be arithmetic? Did I not read that carefully enough? Let's go look. Does it say they're all arithmetic sequence? Oh, it does. Look at that. And I didn't underline it. Arithmetic sequence. All right, so we're only looking for, oh, 1 second. My lights turned off. Come on, turn back on. Please turn back on. Ah, I gotta go touch it. There we go. Okay, coming back. So it is an arithmetic sequence, so we're only going to look for a common difference. So we're going back over here. All right, so plus 3 plus 3 plus 3. This is a good example of reading carefully can actually save you some work later. So I didn't read carefully the first time, and so that's why I was considering that maybe it was geometric. But it's not, it's arithmetic. Okay, so an explicit equation, that's pretty easy to write. Let's do that real quick. And I think we'd like doing that in purple. Usually I've done, well, I don't know. We'll do the explicit in, or sorry, the recursive rather. Recursive first. We'll do that in purple. So f of n equals, and it's going to be the previous, the f of n minus 1. And it looks like we're adding 3 each time. So plus 3. And then we should note that f of 1 equals 8. There we go. So that's our recursive equation. Then we have our explicit equation. We'll just zoom in a little bit. Our explicit equation, we're going to do this one in green. So this is just going to be f of n. Come on, f of n, there we go, equals. And now we're going to need to have our starting value, which is 8. Oh, don't do a new note. Ah, it got me again. Delete the note. Okay. So f of n equals 8, which is our starting value. And then we're going to add 3 for each step, but we're going to multiply by n minus 1 because we don't want that first number to be artificially increased by 3. So there we go, n minus 1. All right, let's graph it, and then we'll create a context. The create a context, it really allows for some creative interpretation of what situation might give these numbers some sort of real world meaning. But we'll get to that in a second. Let's graph this first. So let's change the black to be orange. We've liked graphing in orange, I think. And then take the tails off. All right, so we need 1 to go to 8. 1 needs to be 8, and it looks like that is right here. 2 needs to go to 11. 2 has to go up to 11. That's right here. 3 has to go to 14. So 3, we have to go all the way up to 14, which is here. And then 4 needs to go to 17. 4 all the way up to 17 is way at the top, right? That should be 17. All right, so there are 4 points. They are labeled. And now let's get to our creative part. All right, now let's actually look. On day 1, it costs 8. For 2 days, it costs 11. For 3, it costs 14. For 4, it costs 7. So maybe this is like something, maybe you're renting something, right? And renting it for a day costs 8. And then each additional day, they just charge you for 3 more. I don't know. But let's go with that. So this is actually going to be renting the world's smallest bouncy house. We'll just go with renting tiny bounce house. Oh, bounce. That's not good. Renting a tiny bounce house costs $8 for 1 day. And $3 more each day after. Each day. Oh, it didn't write for me there. That's okay. Each day after. All right, that is my proposed context. That's what I've created. You can create something totally your own. It's just that's what I wanted to go for. So, all right, let's move on to the second, number 6. So we're given a recursive equation in this case, which is cool. And now we've got to just change it to explicit. All right, so recursive, it looks like we're starting at 3, and our step is plus 4. All right, so we're starting at 3, and our step is plus 4. So f of n equals, our start is at 3, and our step is going to be plus 4. So we use plus 4 and minus 1, right? Start at 3 and jump up by 4, where the first, right, our first value is going to be that 3, right? So that is what we got. And now, since we already had recursive sort of in black, we'll do purple for the table. We'll do purple for the table. And let's do a table here a little bit. All right, so we'll go n is here, f of n is here. It got me with the note again. Okay. We'll go zoomed in. Oh, we can't zoom in like that because I'm on the drawing tool. There we go. All right. Let's go back to the purple. Okay. If our first, right, this was given by our recursive, the first value was going to be 3, and then it said we jumped by 4 each time. So our second should be 4 higher than 3, so that should be 7. Our third should be 11. Our fourth should be 4 higher than that, 15. And we'll even put a 5th in here, why not? And that's going to be 19. I don't know if all these are going to fit on the graph, but that's okay. We can make them fit on the graph. So let's do that now, actually. We'll change this because I haven't put a scale on this graph yet because I didn't know how high it was going to need to go. So, oh, and I only actually have 4 slots on the graph, so we'll figure that out. So it looks like we need to get all the way up to 15. So we'll just go by ones. How about that? We'll skip over the first one though, so it's like 0, 2, 4, but each line is going to be worth 1 value. 0, 2, 4, 6. That makes this one 8. And then we get 10, 12, 14, and 16 would be this really high one. There we go. All right, so that's 14 and 16. All right, let's add some points. So our first point, our 1 needs to go up to 3. So there we go. That's 1, 3. Then 2 needs to go up to 7, which is here. 3 needs to go to 11. So 3, we go up all the way to 11. That's right here. And 4 has to go up to 15. All right, 4 needs to go up to 15, which is this line here. All right, so there we go. That is all 4 of our points plotted. And we're not actually going to have space for that fifth point on our graph, so that's fine. Now a context. Okay, let's see. What context would make sense? Something that starts right on the first day. It's 3. On the first day of 3. On the second, or this is, I'm saying days already. Maybe it's minutes. Let's do minutes. The first minute there are 3. The second there are 7. And then 11. So there's just 4 more each time. Okay, let's go with the number of people waiting in line for an ice cream truck. Let's go with that, right? So in the first minute, 3 people line up, but then every minute after that, 4 more people join the line. So number of people who have lined up. So in the first minute, an ice cream truck. Oh, did it work? I don't think it worked. There we go. An ice cream truck is open. Three people. Oh, I can write this as a number, can't I? 3 people line up. Then 4 people join the line. Join the line. Each minute after. Each minute after. There we go. So that is our completely made up context. I invite you to be as creative as you want during your context creation, because it's really interesting to think of all the different ways that math could end up in the real world. So let's look. All right. On this one, we're given the context, so we can't actually be creative, but that's okay. We can create a recursive equation and we can create an explicit equation. So we'll start with that. All right, recursive equation. All right, first, what's our context? Janet wants to know how many seats are in each row of the theater. Jamal lets her know that each row has 2 seats more than the row in front of it, and the first row has 16 seats. Okay, so we have our recursive equation first. So that's actually not going to be so hard, right? Because it's saying that, and we always start like this, right? So I'm not really explaining what I'm doing. There we go. So our current step equals our previous step, and then it said that that each row has 2 seats more than the row in front of it. So as we go, like the first row might have some number of seats. It says 16, but the second row would have 2 more. So it's going to say take the previous row and add. Is it letting me? There we go. And add 2. All right, and then it's also saying that the first row has 16. Okay, so that's our recursive equation. Now we're going for explicit, so let's change to purple real quick. We'll just change it up. So f of n equals, now we always start with our starting value, right? So 16, and then we're gonna say it's plus 2 for each step, n, but we're not gonna do that for the first step, so we have to take away 1 for the first step, so n minus 1. 16 plus 2 times n minus 1, and now we will create, we'll use black. Actually, should we go back to green? We'll go back to green. How about that? All right, back to green to make our table. So we've got 16. So let's see. N is going to be the row number. Oh, did it let me draw that? Not really. So N is going to be the row number, and F of N is going to be the number of seats. So that's fine. All right, and we know that the first row had 16 seats. That was given in the context. The second row should have 2 more seats than that, so 18. The third row should have 20 seats, and the fourth row should have 22. All right, so that is that's all we're going to need space for, because our table, or our graph rather, only has 4 spaces for it. So let's start filling in this table. So the first needs 16. All right, so that's way up to here. Our second needs 18. Second up to 18 is here. Our third needs 20. That's going to go up to here. And our fourth needs 22. Fourth needs 22. Excellent. So that is our graph for this situation. And now we will read the instructions for the next section. Use the given, oh, and there go the lights. I knew it was coming this time. It turns out that there's a little chirp that happens. And I don't know if you can pick it up in these videos, but there's a little chirp that happens in this room that basically says the lights are about to go out. So, all right, so reading the instructions for Go, use the given recursive equation to write the corresponding explicit. All right, so we're using a recursive, use recursive to write explicit. All right, so we're writing explicit. Write the explicit equation. That's all we're trying to do. Just write the explicit equation. So let's go do that. We work across, oh, and this has got to be, yep, this is going to be the last one of the unit. Here we go. So here's a recursive. Oh. Here's a recursive. We need to write an explicit. All right. So it looks like whatever our current is, right? So this is, oh, it's not letting me write. That looks like car. I don't want it to say car. I want it to say current. Let's try that again. So this is our current. And this is our previous. And what it's saying is our step, right? Our step is take 2 away. All right, and then our start is 8. Oh, that's not quite right. Our start, wow, that wrote really badly. Let's try that again. Our start nope, not quite. Our start is 8. All right, there we go. Wasn't supposed to be that hard, but we'll make it happen. All right, so our explicit rule for this, there we go. Our explicit rule for this is going to be f of n, as it always starts out. F of n equals, what are we doing here? Well, we're going to need to use our starting value, 8. And then we're going to have to incorporate our steps somehow, so we're going to take away 2 for every n minus 1. Right? So we actually use the previous, the step, right? All of these parts, the current, the previous, the step, and the starting value, all end up in our explicit, right? This is our current, right? F of n is our current, 8 is our start, minus 2 is our step, and then the n minus 1 is the previous. So all the same portions in the explicit and the recursive, just different orders. And when we write it explicitly, it all happens with 1 equal sign. So that wraps it up. Hopefully these have been helpful.